Welcome to On the DOT. On today's episode, we speak to INDOT engineer Jeremy Hunter. Jeremy answers all of your burning questions about bridges. He tells us about bridge terms and how they are used and sometimes misused. We also talk about what we look for when performing inspections and how different types of bridges require different types of maintenance. Jeremy also answers one of the most frequently asked questions about bridges: why do we paint them blue? Before we begin, please take a moment and download the INDOT app for Apple and Android devices. You can also listen to the previous episodes of On the DOT by searching INDOT on YouTube. Now let's join INDOT Southwest Communications Director Jason Tiller for his conversation with Jeremy Hunter.
There's never been a better time to start your career with INDOT. Entry-level positions now start at $19 an hour, and with a CDL you can earn even more. Go to INDOTjobs.com or text INDOT Careers to 468-311 to apply now. Welcome to On the DOT. I'm Jason Tiller, your host, and I am joined by Jeremy Hunter. And Jeremy, I don't know your actual title because we didn't discuss it right before we jumped into this, but I'll let you say that. But I'm going to call you for now the Bridge Guru.
I appreciate that.
Yeah. So Jeremy, what is your title?
So I'm the Chief Engineer of Design, Managing Director of Engineering, responsible for a lot of the design services that INDOT produces.
Okay, so what you're telling me is that you're a really smart person. This episode kind of came about as a response to the general public and also the media asking about bridges. And, you know, it's one of those things where bridges kind of has a weird, or bridges, I guess. I don't know how I should say that. But anyway, when you're talking bridges, there is terminology that is not necessarily clear. And it wouldn't be clear to the general public, somebody who, is not educated on all things bridge related. And so, if you don't mind, Jeremy, let's just jump into some of this stuff. And can you kind of explain to us what some of these terms mean? Like particularly like you hear obsolete or functionally obsolete or structurally obsolete. And when I hear that as a person who is not any kind of versed in bridge engineering, I hear that and it sounds scary right off the top of my head. So can you kind of explain why that is not necessarily a scary thing? Absolutely.
So when the National Bridge Inspection Standards were created, it's probably 60 years ago now, that they came up with a lot of ways to categorize bridges. And so a lot of that was based on the condition of the bridge, but some of it was not. Some of it was based on what the bridge consists of. And so it was a way to help state DOTs and the engineers be able to assess what the bridge actually consists of. And so the term functionally obsolete was actually defined based on what the geometry of the bridge was for the roadway coming in. And so when you had a bridge that was maybe a lot narrower than the roadway leading up to it, which we've all seen and experienced and driven over safely, it was determined to be functionally obsolete because it was narrower than the approach roadway coming in. And so that actually is a term that we don't really use anymore. Federal Highway stopped using that terminology a few years ago. And one of the reasons why they stopped categorizing bridges that way is because we realized that really a bridge doesn't need to be a lot wider than the roadway leading up to it. And so you really want the bridge to kind of fit in with the context of the roadway. And so that's why we don't necessarily use that term anymore. And instead, when we go out and assess a bridge, we try to take a look at who uses the bridge, how wide does it need to be based on the roadway that's leading into it, and are we ever considering widening that roadway?
So what you're saying is that, when we see those narrow bridge signs, that would have been, ever how many years ago, that would have been considered functionally obsolete, correct?
Correct.
Okay, so in that scenario, you mentioned that, the bridge doesn't necessarily need to be a lot wider than the roadway. Can you kind of unpack that a little bit for me?
Sure. So we have design standards for our roadways, and so we try and determine how wide the lanes need to be and how wide the shoulders need to be, and some of that is just based on how the road gets used. And so if it's interstate, Obviously we want nice wide lanes and shoulders because we have a lot of heavy truck traffic using that roadway. If you're on a county road, it's usually a lot more local traffic, and so you can get by with a narrower roadway, and so the bridge, we really just try to line up the width of the bridge with the width of the roadway that's coming into it.
Okay, so basically, and the term functionally obsolete is now an obsolete term. So we've explained that very well, and I think maybe I have a little bit more comfort about that. But let's talk about some of the other bridge terms, particularly structurally obsolete is something that I've heard quite a bit. And, I'll reference bridge reports that I've seen and that the media gets hold of, and I think they come from Federal Highway. But, they'll say, oh, this bridge is structurally obsolete. Now, can you kind of unpack that term for us?
Sure. So the term you're referring to is structurally deficient.
Okay, so structurally deficient. See, I don't even have the terms right.
No, that's all right. It's easy to get them confused. So, yeah, structurally deficient, what that references is, as I started off talking about the National Bridge Inspection Standards, and there's a number system that they use to classify the condition of the bridge. And so there's training that every bridge inspector is required to go through that helps them understand exactly what number to rate that bridge. And so we typically see numbers of 4 would be what we would consider poor condition, something that we would look at that we wanted to repair. 5 and 6 we would consider to be in fair condition. 7 and 8 would be in good condition. And so when a bridge gets in towards that poor condition, really what that means is it's not an unsafe bridge. What it means is that there's a component of that bridge that has served its useful life, and it's time for us to start looking into repairing or replacing that component of the bridge. And so when you hear the terminology structurally deficient, which I think Federal Highway's trying not to use that terminology quite as much anymore as well, but when you hear that terminology, really what it means is that there's something on the bridge that we're wanting to repair. But the most important thing to know about that is that the way that it got to that condition rating is an inspector went out. We go out at least every 2 years, and oftentimes more frequently if needed. And the inspectors will go out, they'll take a look at the bridge and assess the condition of the bridge. When they lower the rating of that component to say that it's time to do some work on this part of the bridge, they'll also do a safety inspection and make sure that bridge is still safe for use. If there's any questions about that, we actually have additional processes where they can come in and assess what the level of safety the bridge is still providing. And so if an inspector sees a component where they have a lot of concerns, if maybe it has a lot of what we call on steel bridges, we call it section loss, where you're getting a lot of rust, and so you don't have as much steel as you did the day it was made. And so the inspector would then trigger an analysis by our engineers, and we would do what we call a load rating analysis, where we would do detailed calculations to determine how strong is that particular member compared to when it was originally created and compared to the loads that we know will be using that bridge. And so with that analysis, that load rating, we're able to determine how much that bridge can still carry. And if there's any questions about whether or not it can carry the full legal loads that we would normally send over that bridge, we would actually put a load posting sign out in advance of that bridge, so that way we know that loads that are heavier than we want can no longer cross that bridge. And another thing I'll mention is that's really important to know is that everything we do has a factor of safety involved with it. So we're always erring on the side of conservatism. We always want to be conservative and be extra cautious and safe, because the most important thing we can do is protect the traveling public.
Yeah, absolutely. And so kind of to summarize what you said, basically, we have that bridge rating condition, and that is based on federal standards, and they can be in poor, fair, or good condition. And just because a bridge is classified as structurally deficient, not obsolete, deficient, that doesn't mean that it's unsafe. It means that it's if it's structurally deficient, it's down there in that 4 category. You got to think of it kind of as any routine maintenance type of, as things get older, they start to show wear, and you got to start thinking about performing maintenance on it. Is that kind of
very similar? Yes. And so I just had to replace my roof recently, and so a good analogy would be that my roof, I would have said, if I was qualified, I would have said it was in poor condition, and it was time to replace it. But that doesn't mean it was unsafe. My family and I, we stayed in the house until the old roof was off and the new roof was on. And so it's very similar with our bridges. They have a service. There's components that have a service life, and as we start to near the end of that service life, we just then program the bridge for work to be done to replace those components to keep it in good, safe, serviceable operation.
All right, perfect. So we'll get a little bit more into inspections and things like that in the next segment. But before we jump to the next segment, I want to ask one more question. Now, there is a classification under Federal Highway, and I'm not even going to pretend to know what it is now because I embarrassed myself earlier. But what is the classification for, say, a bridge that we wouldn't design in 2021, but maybe in 1940, that was kind of the big, the trendy design? What is the term for that, and can we kind of unpack it a little bit?
Sure. So we have what we would call historic bridges, and so a lot of times a bridge, to be classified as historic, usually has to have some unique features that make it, I guess, for lack of a better term, interesting, and so architecturally interesting, and so a lot of those bridges, we do try to retain, because there's essentially, not only are they providing a service to the community in terms of allowing people to cross that road or stream, but they also provide kind of a cultural significance. And so with historic bridges, we try to take special care to make sure that we're retaining that bridge within the condition that it was originally built to, and with a lot of the standards that it was built to. We have other bridges that are from that era. That maybe aren't particularly interesting to the casual observer, but those bridges, they've performed, maybe for 70, 80 years with great performance. And so those bridges, we would continue with our routine bridge inspections to monitor the condition of them. If they're still performing in good good service, what we would expect out of that bridge, we'll determine how we can continue to use that bridge, or if it's time to replace it, we'll program it for a bridge replacement and replace it with a modern structure.
Yeah, absolutely. And so kind of what I'm getting at is, there are bridges out there, like, we got truss bridges all over. I don't know how many we actually still have. I know it's one less now that the Pigeon Creek Bridge on US 41 has been demolished. But we're not necessarily going to build a truss structure in 2021. It's going to be a modern bridge without a height limit, because ultimately you do have that risk out there. But just because those bridges are out there doesn't mean that they are in any kind of danger just because they're old, correct?
That's absolutely correct, yes. And so, like I said, we assess those bridges. A lot of those bridges were designed to different standards, obviously, but we can analyze them with modern techniques, and so we can determine how much that bridge is capable of carrying still. And so, like I said, depending on where the bridge is and how valuable it is for us to keep it in service, we can determine what the safe load is for that bridge, and then we can post with a load posting sign if we think it needs to be lowered. But often we're able to strengthen the bridge, or it's strong enough with its original service to continue to service routine traffic with the factors of safety that we always require.
All right, perfect. Well, Jeremy, we're going to take our first break here, but when we come back, I want to talk about inspections. A lot of people often ask, what do we look at when we're inspecting? And I can't say that I always have a great answer. So we're going to talk a little bit about that and really do a deep dive into bridge inspections when we come back on the DOT.
In 2019, distracted driving was a factor in nearly 2,000 injury crashes in Indiana, killing more than 20 people. To make Hoosier roads safer, hands-free while driving is now the law. That means you can't have a mobile device in your hand while driving. You can still use a phone or tablet in your car, but you must use a speakerphone, headset, Bluetooth, or other hands-free technology. Go hands-free. Learn about the new law at handsfreeindiana.com.
Did you know that INDOT also has an eye on the sky? INDOT inspects nearly 120 aviation facilities in Indiana, including seaplane bases and heliports. To learn more about these and other multimodal programs, go to multimodal.indot.in.gov. We're more than just Hoosier roads.
Welcome back to On the DOT. My guest this month is Jeremy Hunter, and like I said, I'm going to call him the bridge guru because he knows everything that there is about bridges. But he's one of our engineering leads here at INDOT who is so very knowledgeable about this subject. In our first segment, we talked about the terminology of bridges, and it's scary sometimes to hear the phrase structurally deficient or functionally obsolete, and people automatically equate that with, oh gosh, this is going to fall in the bridge or fall in the water, I guess. But we learned that that's not necessarily the case. And we touched briefly on inspections during the first segment. And so I want to kind of do a deep dive into the inspection piece of it. Can you tell me just a 5,000-foot view right now, and then we can go into more detail later on in the segment. But what do we look for when we are inspecting bridges specifically?
Absolutely. So, all of our bridge inspectors are trained to look for very specific things, and so we have different components of the bridge. We have what we call the substructure, which is like the columns and the foundation that supports the bridge from underneath, that most people never get to see unless it's a bridge over the roadway. Then we have what we call the superstructure, which is the components, the beams, the deck, and the railing. That goes over the top of the substructure. And so a bridge inspector would go out and they would look at all of those different components. And they would look for any signs of deterioration, right? Everything over time deteriorates, and so they want to monitor routinely what's deteriorating, how fast is it deteriorating, and then how do we classify that? And so that's essentially what they're doing. They'll also look at if it's over a stream. They'll look at how the stream is affecting that. We have what we call bridge scour, where a stream will remove dirt from around the substructure over time. And so an inspector would take a look at that and see if they notice any signs of scour. And then if it's over a roadway, they would look at the safety hardware leading up to the bridge. If there's guardrail attached leading up to the bridge, they would check to make sure that that's still in good condition and functioning properly. And so they kind of do the full safety inspection is really to assess all those components to make sure they're operating the way that we intended them to.
So I'm glad you mentioned scour because I've always said it like this: scour is basically erosion with just a little bit more. It's a little more complicated than erosion, but it is erosion basically. But we'll talk a little bit more about that in a second. But I want to talk about we have several different types of projects that we do on bridges. We've got several overlays that we're doing in our district right now, but we also have multiple complete replacements, and then there are a couple operations in between those two extremes, I think. So can you explain to us during the bridge inspection what we find that triggers a complete replacement versus a smaller operation like a deck overlay?
Sure. Yeah. So oftentimes with the substructure, as the substructure gets older over time, as it starts to deteriorate, we would basically do an assessment of are the conditions of that getting to a point where within the next 5 to 10 years we would like to see that be replaced, and so that would trigger a bridge replacement. Another thing that often triggers them, and this is probably more frequent, honestly, than the condition trigger, is that maybe we have a different different use for that roadway. And so maybe we have a project coming along where we know we're going to want to widen out that roadway to make it easier for people to get to and from where they want to go. And so in those situations, oftentimes it actually is easier, maybe more cost effective to just replace the bridge with a new modern bridge that's going to have the width that we need and have whatever new safety features we'd like to add to the bridge. And so those are kind of the two criteria that we would use to make that determination.
Okay. So what are common things we find during inspections, particularly with those structurally important components? On both a modern bridge and maybe a historic bridge.
Sure. So one of the things we'd assess, so if it was a steel bridge, we would look at the condition of the paint. We'd try to make sure that the paint's still functioning well. We would look to see, as I referenced earlier, do we have any section loss on the steel? Has it rusted, essentially to a point where you're starting to see some steel disappear. And so we make assessments on those kinds of things. If the concrete components of the bridge, the concrete, sometimes it'll do what we call delamination or spalling. So what a delamination is when the reinforcing steel that's embedded in the concrete, the top layer of concrete will start to separate as that reinforcing starts to deteriorate. And so as you get that delamination, we can sound for that. So we'll actually take a hammer and tap on the concrete to hear, and it has kind of a hollow sound to it. If you hit solid concrete, it kind of has a ping sound to it. And so it's actually an audio test, essentially. And so we'll do that on a lot of the concrete components to assess, are we starting to get some of that delamination? And those things are actually not a cause for concern for us. It just is a sign to us that we're starting to get a little bit of deterioration inside. And so we'll assess what that deterioration consists of. And we'll also usually come up with one of those in-between projects that you referenced where we'll rehabilitate that component of the bridge. And there's a lot of techniques we can use to repair those types of things.
Yeah, absolutely. So I'm glad you mentioned also the audio test. There's quite a bit of technology that we use. I know that in some cases we've used lasers, different things. Can you talk a little bit about some of those techniques to inspect bridges?
Yeah, absolutely. So these are some of the things that for me as a longtime bridge engineer that I get really excited about, because the technology that supports the work that we do has just come such a long way in the last 10 years. And so a few of those techniques, we have what we call ground penetrating radar. And so that actually is a way, it's kind of the Superman X-ray vision, if you will, for bridges, where it can actually see through the concrete and see where the reinforcing steel is located. And we can start to get indications of what the corrosion potential is for that reinforcing. And so we can use that then to actually look through. You might look at a concrete bridge and everything looks perfect on top, but then you'll be able to see what's happening underneath that top surface, which is really exciting. We also use what we call infrared, where it's kind of like a heat map, if you will, where it'll show how the bridge deck is heating and cooling at different rates. And so areas where it's heating and cooling faster, it'll appear in kind of a bright red color on the infrared. And so that will actually indicate to us what I was referring to earlier, like with delaminations, that you're starting to get a little bit of separation between that very top inch or so of the concrete deck from the rest of the deck. And so again, it's not a safety concern, but it does tell us that the bridge is starting to get ready for some work to repair it. And so those are a lot of the techniques that we use. We also have what we call Acoustic Echo, which is just that. Instead of one guy with a hammer trying to sound, a part of the concrete, it's actually a machine that will sound, at very fine increments across the bridge deck, and then it'll provide us data with where we're getting that delamination for the concrete bridge deck. And one of the exciting things we can do with that is everybody, has probably seen or has, maybe hopefully not, but firsthand experience with a pothole. And so what this technology can allow us to do is to know where those potholes are going to form before they ever form. And so we have actually some repair techniques where we can do what we call epoxy injection. So we take an epoxy and we can drill little holes where that delamination is occurring. We can fill it with epoxy. So we know that if we would have let that go 5 to 10 years, it would have turned into a pothole. But the great thing is the traveling public never even knows it was there because we found it with this technology and we were able to repair it before it actually occurred.
And so the next question, I can just hear this from somebody listening. Well, why don't we do that on the asphalt? But anyway, Jeremy, we actually need to take a break. But really quickly before we do, I want to kind of summarize what you had talked about. So basically, when somebody listening, somebody out there on the traveling public, when they see a bridge being worked on and their immediate thought is, well, why are they even doing this? This was a perfectly fine, there was nothing wrong with this bridge. Well, it's not necessarily something you would see at the surface level. We've got all of this technology and all of these different processes in place that tell us, okay, we need maintenance. Is that pretty much it?
Absolutely, yeah. So as I've referenced maybe a few times earlier, we are always going to make sure that we're being conservative with what we're doing. Safety is our most important obligation as engineers and as DOT employees. And so we're always going to ensure that we're repairing things before they would need to be replaced, and before they would cause a problem with the structure. And so that sometimes is what's happening. Sometimes it really is that we're able to use some of these more modern techniques, and then just the skill and training of our inspector community. They're able to see things that maybe somebody who's not a bridge professional would notice with a bridge, and so they see that probably many years before somebody else might notice that, hey, there's something that needs to be repaired there. And so it really is a credit to the work that we do to train the bridge inspectors and just to their skill set and the service that they provide for us, that they can spot a problem before anyone else ever even knows it's going to be a problem, which is how we always want to handle it with the safety of our bridges.
Exactly. Better to be proactive than reactive. So, Jeremy, we'll take our final break here, but when we come back, I want to talk about a couple of miscellaneous questions, I think, that we hear from the public, and just not necessarily problems that they have, but just like, that's weird. Why do we do that? So when we come back, we'll talk about those things. You're listening to On the DOT.
Somebody needs to report that pothole.
Why aren't they mowing the grass in the median?
When are they going to fix this road?
You know there's an easy way to get answers to those questions and report the problems you see on interstates, U.S. routes, and state roads. Dial 1-855-INDOT-4U to talk to a live customer service professional. That's 855-463-6848. Hate talking on the phone or have a fear of human interaction? We've got you covered. Go online to INDOT4U.com to use our Report a Concern tool. You can also report a concern through our INDOT mobile app for iPhone and Android. If you've got questions, we've got answers at 855-INDOT4U or online at INDOT4U.com. Did you know that Indiana is the crossroads of America for railroads, too? Our Rail Programs Office conducts around 1,500 rail crossing inspections every year to make sure conditions and signage meet federal and state requirements. To learn more, visit multimodal.indot.in.gov. We're more than just Hoosier Roads.
Welcome back to On the DOT and our final segment with Bridge Guru Jeremy Hunter. And I hope that's not an insulting thing to say, but I tell you what, you're so knowledgeable about it, and so that's what I want to call you, as the Bridge Guru. But so we mentioned before we threw to the break that there are just some off-the-wall kind of weird questions, and I call them weird questions, but in the minds of the people who ask them, they're legit. And so I wanted to kind of just pose a couple of those to you on behalf of our listeners and the motoring public. So, Jeremy, let's just jump right in here. Why do we paint bridges blue?
So that's a great question, And when I first started at the DOT many years ago, I actually asked the same question. So the answer really is a little bit of precedent. I think a lot of people like the color blue. The color of blue that we use, it's a lighter color, and so that actually makes it easier for our inspectors to see deterioration, and so there's some value to that as well. But when I started at the DOT, and it was actually my job to figure out what color we were going to paint some of our bridges, and so I got to talking to some of our inspectors and asked them, hey, are there colors that work better or worse for inspection? And they said that blue's a good color, that light blue. The green that you see sometimes is a good color. But one of the inspectors mentioned to me that there was a color that's in our specifications that I think it's a taupe color, kind of like a khaki color. And I'm not good with colors necessarily, but I said, okay, well that sounds interesting, and so I started specifying that color of taupe, that kind of khaki color for a lot of our bridges that we were painting in those years I was in that position. And so I laugh every time I drive around now, because I'll notice the bridges that I specified, because that color didn't get used a whole lot other than when I specified that. But we do have a kind of a variety of colors, and sometimes on big projects, you've probably noticed that when you're driving through a big corridor where we did a lot of work, we'll actually have an architect as a part of that project who will come up with a color scheme and with a kind of a decorative look to some of the bridge components or some of the highway components, and so on some of our projects will actually use different colors for that reason, because somebody who's more qualified at decorating than I am determined that we wanted to have a certain paint scheme, color scheme for that project, and also the other aesthetic features.
And also, one of the things that I've noticed in my time at INDOT is, say, you've got maybe you're doing a bridge project in a city or something like that, and they've got a particular aesthetic that they look at. Southwest Indiana here is my domain, so I'll make another reference to Southwest Indiana. When we finished the US 41 and Lloyd Expressway interchange, the bridge there, I know that we did a few things. We've got the City of Evansville logo on it, or the words on the bridge. But I know that they had in particular asked that it be painted kind of that khaki color as well. And so sometimes, we do are able to honor those requests from cities or towns that have a specific aesthetic they're going to, right?
That's correct. Yes, and as somebody who loves bridges, I like it when a bridge is kind of noticed by the traveling public. We spend a lot of our time trying to make sure that those bridges are so safe and functional that the average driver doesn't even know when they're going over a bridge versus being on the highway. So there is a little bit of pride when we have a bridge that really stands out, when it's a bridge that really has a nice aesthetic to it that people notice, and then just the value. As a DOT employee, I'm a lifelong Hoosier. I've spent my entire life in Indiana, and so there's a lot of pride for me in our state and in our communities. And so as a DOT employee, we've a lot of us have carried that pride through, that we want to be partners with the communities. And one of the ways that we can be great partners with the communities is to incorporate some of these features in a partnership with those communities to make it an aesthetic that brings a sense of pride to that community. And so like the area that you're talking about, or there's other areas around the state where we've done that, where we've partnered with the local community and allowed the transportation features to become more than just a functional service, but to actually add a little splash of color, which, like I said, I'm an engineer. It's not my specialty, but fortunately there's a lot of really qualified people who are good at that can help us figure out how to make it just a little bit more pleasing to the eye.
So let's take a hard left turn here, Jeremy. We've talked about why we painted the bridges blue. So another question that I hear often is when we're working on bridges specifically, well, why can't we do this under lane restriction? Why do we have to do this under full closure? And in some cases, we can, but in other cases we can't because of the type of bridge. And I'm thinking of one in particular where I think they said it was an arch type bridge or something to that effect. I'm not, the terminology escapes me right now, but basically what it boils down to is because of the bridge type, it would actually be dangerous to close one lane and have traffic on one lane while we're working or replacing the other side. So are there a lot of situations like that, and can you give me kind of some examples of the types of bridges that are like that?
Sure. Yeah, so there's a lot of bridges that they use different support mechanisms, and so a truss bridge might be an example of that, where if we needed to do a lot of work to one side of the truss, if we needed to disassemble that side of the truss, well, then it would compromise, because then you only have one truss left. And so in those scenarios, and as I've mentioned, we're always going to make sure we're making the safest choice. And so if we're doing anything where we think that there could be a concern about the ability to continuously carry the traffic over it, we're going to close the entire bridge and come up with a reasonable detour for traffic to do that. Sometimes it's necessary so that we can do the project a lot faster. It really slows down the contractor's ability to do the work if they have to work half at a time. And you build in some things that are safe, but long term they don't provide is the best long-term serviceability. And so if you have joints in the concrete, those are things we like to avoid, because it's just a place where over time water could leak, and kind of like my roof analogy, you want as solid of a roof as you can have, because any break in the roof is a place where water can leak. And same thing with our bridge decks. You want to try and keep it as uniform as possible. And so when we're able to close the bridge, that gives the contractor the safest working environment. If we can have a good serviceable detour, it gives the traffic a way to avoid the construction and not be interrupted by it. But then maybe most importantly is it allows the work to get done considerably faster. And so we can, get in, get the work done, restore that bridge to a great condition and get people the opportunity to use it again just the way they always would. So those are a few of the different considerations that we use. You asked about examples of bridges that maybe we would need to close for that, and so the truss situation is one example. There's some where if the substructure has what we call a hammerhead pier, where that pier is a little wider than what the foundation is. That's kind of an older design, but those existed as well. And so what we would do is we'd analyze how much of that are we needing to close down, and how much of that support is able to service the traffic, and if we're having to push the traffic too far out, we'd say it's going to be better to close that bridge down. And so there's a few different situations like that. And the exciting thing about being a bridge engineer is there's so many different types of bridges around the state, and so every project really is kind of a new adventure, to determine what the best way to deliver that project is, and then most importantly, we always determine what's the safest way to deliver that project.
So just for those listening who are motoring public who are not bridge engineers, there you have it. It's confirmation we don't just do this willy-nilly. It's something that we give a lot of consideration to whenever we do close a bridge. So, Jeremy, we're winding down here and running a little low on time. So I wanted to ask you just really fast, you mentioned there's so many types of bridges. There's so many cool bridges in the state of Indiana. Which ones come to mind when you think of cool bridges? Kind of what are your favorite ones?
Sure. So the trusses that we've talked about are obviously for a structural engineer. They're kind of a beautiful thing to look at because the pattern of the truss actually lines up with the way the force would be transferred through, and so it's kind of like an engineering diagram in a sense to look at a truss. But some of my favorites. So I mentioned I'm from Indiana originally, and so growing growing up, I remember there was a covered bridge that was not far from my home, and so as a kid we would go out and cross the covered bridge, and we have a lot of covered bridges in Indiana, and in my mind they're all beautiful. Just that era of using wood and being able to, how they were able to form the wood to the shapes that they wanted, which I can imagine was not an easy thing to do, and they as well, not only have that aesthetic beauty, but as a structural engineer, there's the beauty of seeing the trusses inside the covered bridge. But if I had to pick one that I guess I would say is my favorite in the state of Indiana, we have a few bridges. We don't have very many of them, but they're called open spandrel arches. And so they're these concrete bridges. They're usually fairly good-sized bridges. And when you drive over the top of them, you wouldn't even know that it's any different kind of bridge. But when you actually go down and are able to see it from underneath, they have these big, beautiful concrete arches. And then on top of those concrete arches, they have these concrete columns that all frame up into that superstructure that I referenced earlier. And so just how much of a clean look they are, and just how, as a structural engineer, you can see the arch shape, you can see the columns, you can see the girders and the superstructure. So I've always found those to be just really kind of a visually appealing and kind of a special bridge.
All right, very cool. Well, Jeremy, we're out of time for today. Thank you for coming down, and I do want to say a special thanks to our Linton Subdistrict. They have once again provided us a space to have this conversation, and can't be more grateful for that, because we have a lot of people that come down from Indianapolis to southwestern Indiana. So thank you for coming down and taking the time to be with us. And I really feel like we've gotten a really good education today on bridges, a crash course maybe, but definitely something that we can walk away and say we didn't know before. So Jeremy, thank you for being on.
Well, thank you so much, Jason. I really appreciate it.
Mechanics. How does $20 an hour sound? Equipment mechanic positions now start as high as $20 an hour at the Indiana Department of Transportation. You don't have a CDL? That's no problem. We'll pay for your training, and you'll still make $19 an hour until you get your CDL. There's never been a better time than right now to start your career at INDOT. Go to INDOTjobs.com or text INDOT Careers to 468-311 to apply now.
Thank you for listening to On the DOT. Be sure and subscribe on Apple Podcasts, Google Play, or wherever you get your podcasts. If you enjoy this show, please spread the word by leaving us a 5-star review. INDOT is on Facebook, Twitter, and Instagram, and also on the web at indot.in.gov. The INDOT app for Apple and Android devices can be a handy tool if you're looking for road conditions or project information. To report a concern on a number state route, U.S. route, or interstate, please call our toll-free number at 1-855-INDOT-4U. You can also report your concerns online 24/7 at indot4u.com. Thank you for listening and safe travels.